Students, welcome to the final lesson for Unit 7, Circles. We're going to be talking about circle equations. Remember, I still expect you to get a date, time, location, although most of your location's at home, as well as a signature from a parent that they witnessed you actually doing this video, if at all possible. Alrighty, taking a look here at this page, your job is to find all possible arcs and angles in both of these. You're going to attempt to do it on your own. And a major benefit, I want you to show your math in the margin. In other words, you're not using a calculator for two-digit addition and subtraction. Pause the video, do your own work, and then correct in red pen. I'm going to be looking for that. Pause. Alrighty, we're zoomed through this. Welcome back. Hopefully you actually followed my directions and you're just correcting right now. If tangent to a radius, 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 tangent to a radius, right angle at the edge. Measure of a central angle to its arc the same. And go around this way. 360 minus 110. Again, 250, because I said all arcs and angles. This angle back here is going to be big arc minus little arc over 2. So big arc, 250, minus the little arc, 110. It's 140 over 2. This is 70. Another way you could have done this is the fact that this is a quad and adds up to 360. So there's all your arcs and angles for this one. Here, tangent to a radius, right angle at the edge. You have a right angle there. If this is 138, this angle right here is going to be 42. You should have noticed that you have all congruent radii, which makes this isosceles, which makes this also 42. 42 plus 42, take away from 180. That's going to be a 180 minus 84. Of course, that's 96. And then this is going to be 84. And then the question is, what is this angle way out here? This adds up to 180. So that's going to be 90 minus 42. And this is 48. Now, I also asked for arcs and angles. So if this is 96, this is 96. This is 84, that's 84. And of course, don't overlook the 180. Alrighty, again, red pen. I expect you to correct your work. What we're learning about today is equations of circles. Equations of circles. Center, radius, equation, distance, ellipse, and a circle. You guys have mostly and exclusively focused on equations of lines. Just as an example, of course, the infamous y equals mx plus b. One of the most common equations of a line. This, we're going to start focusing on what are called equations of conic sections. Conic sections are different shapes that are cross sections of a cone. That's why it's called conic sections. And they are, if you slice a cone straight across, you get a circle. If you slice a cone at a slant but go all the way through, you get an ellipse. If you slice a cone that goes towards the bottom, you get a parabola. And then you have, if you have two cones back to back, you have something called a hyperbola. All of these are called conic section shapes. And they all have what are called conic section equations. Don't panic. You're not learning all 4 of these. We're only doing the circle. You'll encounter the other 3 in Algebra 2. The circle is by far the easiest. I'd like you to put your finger right here, and you're going to read out loud the definition of a circle. Put your finger right at the "the." I expect you to read out loud. Ready? Read. The set of all points which are equal distance from a single point. I'd like you to read that again. A circle is the set of all points which are equal distance from a single point. Now, we're going to read it and trace at the same time. Ready? A circle is the set of all points which are equal distance from a single point. Did you guys see what we traced? It's really important. I'd like you to trace and say at the same time. This is very, very important. A circle is. Ready? Trace and say. A circle is the set of all points which are equal distance from a single point. When we say equal distance, it means all of these points are equal distance from the same point. When I said that word distance, you should have noticed what we actually traced was the radius of the circle. So this is what I'd like you to associate with. The word distance is now being associated with the word radius from this definition. So let's start by writing out the distance equation. The distance equation is distance equals giant square root, subtract the x's, squared, plus subtract the y's, squared. Go ahead, let's add the subsets. The first point, second point, first point, second point. So we're going to label here our second point is the distance here, because we're reading from left to right. And so our first point is right here, x1, y1, because we're reading always usually from left to right. So we just associated the word radius with distance. So we're going to rewrite distance, but instead of distance, we're going to write radius. Radius equals giant square root, subtract the x's, squared, plus subtract the y's, squared. You want to copy it just like this. But because that single point, the center of a circle, is so important and it's distinct from all of these points, when we say the set of all points, we have a special coordinate system we use just for the center of the circle. And we use the variables h and k for the center of the circle. So we're going to rewrite the distance equation, but instead of x1, we're going to use h, and instead of y1, we're going to use k, because that's the designation for the center of a circle. So the radius equals radius equals x minus h parentheses squared plus y minus k parentheses squared. All of this is based on the definition of a circle, in which we say a circle is a set of all points which are equal distance from a single point. That's why we're using the distance equation. So far, this is the equation we have. Go ahead and recopy it to this page. That's what we used. Now, one last step in building a circle equation. Generally, we don't like giant square roots in our equations when we're dealing with conic sections. It gets confusing. So the opposite of square rooting is squaring. The opposite of squaring. So let's write it like this. So we square both sides. So we have r squared equals x minus h parentheses squared, y minus k parentheses squared. So the final version of the circle equation, normally we just flip it around the other way, that you have it in textbooks. So here's your final equation, parentheses, and this is the one that you must memorize. This is the equation of a circle. Oh, the standard equation of a circle. X, y, x minus h parentheses squared plus y minus k parentheses squared equals radius squared. This is what is considered the circle equation, the standard circle equation. This must be memorized. You're going to have to do 3 things with this circle equation. Build it, pull apart, graph. Build an equation, pull it apart, and graph. Trust me, this is one of the easiest lessons of the year. This will barely take 10 minutes. Ready? First, we're going to build an equation. It says, write an equation of a circle with a center of -3, 0 and a radius of 2 root 7. So let's draw ourselves a picture of the given information so it's easy to see. The center, which is the h and the k, is going to be -3, 0. That's our hk. And our radius is 2 root 7. Now we're going to build our equation. We start by simply writing the equation of a circle, and you're going to rewrite this every single time. And that's x minus h parentheses squared, y minus k parentheses squared equals radius squared. This is the equation of a circle. Now get ready to circle stuff, because I'm going to show you how to plug stuff in. Circle, plug, chug. Circle the -3. You're going to draw an arrow right there. We're going to plug in -3 right there. Circle the 0. We're going to plug 0 right where that k is. Circle your radius. Radius is going to go right there. Okay, now you're going to bring your equation down around it. X minus h parentheses squared, y minus k parentheses squared equals 2 root 7 squared. Now all we do is what we call clean up. We're going to clean up just a little bit. We're going to clean this up, and this up. Let me show you what I mean. Final version. X Double negative makes a positive. Y minus nothing is just y. Now this, let's do in the margin so you don't make a mistake. 2 root 7 times 2 root 7. Outies, innies. That's going to be 4. 2 times 2 is 4. Root 7 times root 7 is 7. So 4 times 7 is 28. That's it, folks. You are done. You have built an equation of a circle. X plus 3 parentheses squared plus y squared equals 28. Ta-da! You have built, you just finished building an equation of a circle. Okay, that's the easiest step. Next, we're going to pull one apart. You start by writing the original equation always right underneath what you're working with. Super important, you rewrite this equation every single time. It's x minus h, parentheses squared, y minus k, parentheses squared, equals radius squared. Now look very carefully. There's our original h, there's the result. Here's k, there's the result. R squared, there's the result. So we're going to pull out what our h, our k, and our radius is. Take a very close look here. If the original equation is minus h, and we end up with a positive 2, the only way you get a positive 2 is if the original input is negative, and you end up with a double negative. Therefore, x minus h, and you end up with x plus 2, the h must be negative 2. Y minus k, notice the sign did not switch, therefore what k must be is just a regular positive 5. If I put a negative there, it would switch the sign. If r squared equals 49, that means our radius must there be 7. And we're done. Our center is negative 2, 5, our hk, and our radius is 7. That is called pulling an equation apart. I'd like you to pause the video here and just verbally rehash, what did we just do? Pause the video, take about 30 seconds, tell it again to yourself, and then restart. Pause. Welcome back. Okay, the last skill after build, pull apart, is graph. And the reason why we do it in that order, in order to graph, you have to be able to pull the equation apart. Start by writing the original equation underneath what you've been given. All right, now we're going to pull it apart. We ask ourselves, if the original equation is minus h, and the final results is plus 5, what was h? If the original equation is minus k, and the results is minus 3, what was k? If the original equation is r squared is 16, what is your radius? I'm going to pause for about 20 seconds. I want to see if you can't fill in those blanks before I show it to you. I'm going to wait 20 seconds. Alrighty. So our h has to be -5, our k +3, and if r squared equals 16, our radius is 4. I love graphing circles. They are so very easy. We're going to start by graphing our HK, which is the center of the circle. There's our HK, -5, +3. Then we're going to do 4 guide points for our radius. I'm just going to go north, south, east, west. So north 4, 1, 2, 3, 4. South, east, west. Now with those 4 guide points, you just do the best you can to sketch a circle. And no, I am not going to grade your artistic abilities here. If it looks circle-ish, you are good to go. If it looks like a squishy diamond-like circle, we're fine. You artsy students would probably do a better job than I am right now. I usually go back and cheat a little bit and smooth it out. Ta-da! There you go for graphing your circle. To recap, you pull out your HK, graph it, and then you count out your radius, north, south, east, west, 4 guide points. All right, you're going to do one of each. Build, pull apart, and graph on your own. Pause the video, do the problems, and then restart. Welcome back. Let's see how you did. So our h goes there, -2. Our k goes there, -5. Our radius goes right there, 3√5. And you should have cleaned it up. Here's the cleanup version. X, double negative, makes a positive. Y, double negative, makes a positive. And this, let's do it in the margin. 3√5 times 3√5. Outies, innies. 3 times 3 is 9. √5 times √5 is 5. 9 times 5 is 45. You're done. Make sure you correct your work. If you got any of that wrong, I expect a little note in the margin. What are you going to remember next time? That's building an equation. Pulling one apart. X minus h, parentheses squared, y minus k, parentheses squared, equals radius squared. Our job was to find the h, the k, and the radius. So taking a look here, and you're asking yourself this. X minus what is just x? X minus what is just x? X minus nothing is x. So your h had to have been a 0 there. What swapped those signs was a double negative, so you had -7. And then we have r squared equals 64, therefore the radius has to be 8. And that's how hard this is going to get. H, K, radius. Last one, I'd like you to pull this apart, graph it. X minus h, parentheses squared, y minus k, parentheses squared, equals radius squared. We're going to pull out our h and our k. Our h is +5. our k, if y is by itself, our k had to have been 0. And if r squared equals 25, your radius must therefore be 5. Okay, we start by graphing 5, 0. And now we count our radius out, or you should have. 5. Here is your circle. Hopefully you do yours a little bit more accurately than I did mine. Build, pull apart, graph. I recommend you set a timer for 2 minutes and just verbally recap what you learned in this lesson. It will help increase your retention significantly.